workshop is going to be around understanding multiplication and division using our current curriculum, math curriculum, which is Amplify Desmos. We hope that, with the help of our wonderful team members actually, Liz and Beth, our parents will be able to engage in activities around addition, multiplication. They're going to do math together and experience the joy of mathematics. They will build understanding around how multiplication and division concepts develop across grades. They will they will also experience tasks similar to those students see in Amplify Desmos mathematics. And we will share ways to support our parents' mathematical thinking at home. So we hope that you find this experience a useful one, and we hope that you engage in activities with our team, with your children, and just have a similar fun that our children have when they are with their math teachers in our schools. As always, we're here for you. We truly appreciate that you took the time to meet with us and engage in these activities tonight. So we truly appreciate you and your children. As always, please feel free to reach out if you have any questions or any recommendations, and give us feedback about tonight. Thank you, Louis. Back to you.
Very good, very good. All right. And we are going to go ahead and hand it over to Beth, who will start the presentation.
Okay, good evening, everybody. So excited to see so many families here. Hopefully, some of us have been attending our last session. Tonight's session is just a continuation of the work that we did back in, I believe it was November, where we thought about addition and subtraction across K to 8. Tonight, we're going to see how that work of addition and subtraction kind of supports the work of multiplication and division that's done throughout K to 8. And as Umit had said, tonight's session is designed not only to give you a peek as to like what your students engage with in school when it comes to learning multiplication and division, but to also support some of your own understanding in of those concepts as well and how they live across the grades. Okay, and as I think I introduced myself, I'm Beth Eaton from the math team at District 25. So, just again, welcome everybody. We do have a packed session, a packed 1 hour session tonight. We're going to spend some time. Again, this is an hour, and we're going to think about what multiplication looks like across the grades, kindergarten through 8th grade. And so I'm really just giving you a very high level overview of these concepts. But we're going to do some math together to experience the joy of math, but also to help us think about multiplication and division, the relationship between them, and how they grow across the grades. We're going to help build our family's understanding of how, sorry, I just said that one, how multiplication division develop across the grades. We'll experience some tasks that are similar to the ones our students see in Amplify Desmos Math. And just to clarify, currently at the moment, District 25 middle schools are all using Amplify Desmos Math in grades 6 through Algebra 1. We do have some schools that are piloting it as part of the New York City Solves initiative in grades. Some start as low as 3rd grade, and some have 4th and 5th, and some are just only 5th. So there's about 11 schools that are piloting it in some capacity for grades 3 through 5. Our hope is that sooner than later, we would be able to adopt this curriculum across K through 5, but nothing has been decided upon yet. Lastly, tonight, I want to just help share some ways that we can help support that mathematical thinking at home and really have some fun together tonight. So I'm going to post a poll. Sure, where did I see it before? And just going to start here. So in the chat, I know the snow has been on everybody's mind. And tonight I'm also asking you to think about supporting your child's math learning of multiplication and division at home. So sure, some of these images spark some feelings for you. Take a minute and just share which of these images of maybe this past weekend and your excitement or frustration levels kind of lend itself well to how you feel about supporting your child with math at home. And if you want to put in the chat why, you're more than welcome to do that as well. Or if you'd like to come off mute and share, you can do that too.
Yeah, if you want to speak, just raise your hand and we'll get you unmuted. Or you can use the chat to give us your comment on the different snow pictures that Beth is showing us. It's too soon to see these pictures.
And I see about a quarter of us feel like number one, which is exciting. It looks like we're like, yay, we love to do math with our children. Happy to see that nobody feels like image number two, where it's like, I just don't even know where to start here. Like, I just feel so snowed in. A few of us feel like three. I'm curious to see, we have about 20% of us that said you felt like image three. If anybody wants to share why that image said. Somebody said it's hard to figure out how to explain something I already understand easily to my third grader. Yes, definitely agree with that. When some things come so naturally to us, sometimes it's really hard to break down the process to our students in a way that makes sense for them. And so I'm gonna also ask you to think about through tonight how maybe you can use some questioning also to kind of support in where they're at. All right. Just see if we have, some of us put, about a quarter of us put image six. Maybe it looks like a group effort when we all work together at home and talk about multiplication and division, the task might seem a lot easier. Perfect. So I'm going to end our poll. And I just hear somebody else like echoing that it's hard to explain multiplication and division. I agree. So I'm going to end our poll here and we're going to continue on. I'm hoping by the end of tonight, you all feel like number one when it comes to teaching, supporting with multiplication and division. Okay. Just a few norms. Cameras are optional. If you'd like to turn your camera on, we always appreciate it. We do value active participation. So I try to make my sessions interactive. We're going to do some math. If you want to put your thinking in the chat or your responses, that would be great. And then just know, like, my biggest one is that there's no pressure to be correct, right? We're all here to learn. Every time I go to any type of math learning session, I always feel like I walk away with a deeper understanding. And so there's no pressure to feel like, oh, I wish I had done this, right? Or I made a mistake here. Through our mistakes is how we learn. So we're going to start with a warm up. We'll start off just tonight right away doing some math. Tonight's math is going to be a number talk that comes from Amplify. We're going to do some multiplication. So I'm going to ask you when I show the next image to just think silently about how, not only just what the answer is, but what your strategy is. And once you have an answer and a strategy, really the strategy more than the answer, if you want to type it in the chat, you can do that. If you put your hands up, we'll allow you to come off mute and share your response. So the first one is 2 times 31. Try to determine the value of that mentally and think of maybe more than one strategy. So if you have one way you think about it and you want to come off mute and share your strategy, great, or put it in the chat, that would also be great. Great, I see an answer. Deborah, want to share how you thought about that? Somebody I see is using, I see a couple of people saying repeated addition, right? 31 plus 31 to get to 32. I'm sorry, to get to 62, excuse me. And then somebody also is saying that they were thinking about it in terms of maybe a little bit more standard algorithm where it's like the two times two ones times or two groups of one is two, and then two groups of three or three tens would be that 60, so 62. Awesome. Okay, so our next one is going to build on this one. I want you to think how you might use maybe your same strategy that you used or how what we just did right now can support you in solving the next one. So now we have 8 times 31. What is that? How might you use what you just did for 2 times 31 to help you figure it out, or is there another way? Mentally, thank you. All right, I see. Do I have anyone brave enough to come off of mute and share how you thought of 8 times 31? Sure. Rachel? Can we have Rachel? Lewis,
Rachel, you
come
can
in?
unmute now.
Okay.
Okay, thanks, Louis. Well, I did 8 times 30 and then 8 times 1 and added those two sums together.
Awesome. So thinking about the place value of each, right? So we know the 3 and 31 is 3 tens or 30. And we could do 8 times or 8 groups of 30 to get 240. And then you said the 1, that would be 8 groups of 1. And that is 8 and add those two together. Awesome. Desiree, I'm going to highlight Desiree's strategy. She said 62 times 4. I'm just curious where you got that 62 times 4 from. Anybody know? So we would get 31 times 2 is 62. Awesome. And then if we had two groups of 31. Now if we're going to take 8 groups of 31, it's like 4 more groups of 2. So we could have done 4 times 62 or added 62, 62, 62, 62, or we could have doubled the 62 to get 124 and then even doubled that again to get 8. Great. So think about what we've just done, and now I'm going to give you the next one. And if you have a strategy that you already feel comfortable with, maybe try one of the other ones we talked about. So what is 9 times 31? And how could we use maybe what we just did to help us? Maybe we have an idea how we could use 8 times 31 to help us figure out 9 times 31? So I see our answer 279 coming in, thinking about it in terms of maybe more standard algorithm. I'm seeing Desiree and Rachel saying like we could have, if we already know that 8 times 31 is 248. If you have 9 groups of 31, you have another group of 31, and you could have just added that to there. And like these are the types of things that we really, not necessarily in our lower grades, but as our kids progress through the grades, say 5th grade, 6th grade, these are the types of relationships we want them to really be paying attention to as they're doing mathematics, right? And so for our last one, I'll just ask you to think about which of these expressions here could help you figure out this last one. So if we have 11 times 31 or 11 groups of 31, how could you use what we've already done to help you figure out what that is? So maybe I'm seeing some answers coming in, 341, maybe some ways, right? If we know that 2 times 31 is already 62, and we just found out that 2 times 79 is, I'm sorry, 2 times 31 is, excuse me, 9 times 31 is 279. We could have added the 62 plus the 279 to get that 341. Or I'm seeing somebody else thinking about the place value, right? So 110 times 31 is 310. And then one other group of 31 is 31, and then we add those together, right? So great. So two different ways to solve it. That sometimes feels when we teach our kids things like this to really think about the relationships in the quantities that exist, sometimes makes it easier than that standard algorithm. I'm not saying I don't use standard algorithm. I'm not saying that it's not something that students don't need to understand, right? It's a 6th grade strategy, but for kids who are struggling, teaching these types of relationships will really help build that fluency. And we've heard, if you listen to our new chancellor, Kamar Samuels, he's spoken a lot about supporting students with fluency. And fluency is not just, in multiplication, is not just doing a bunch of index cards to learn your facts, right? It's also about thinking about the relationships between the quantities and how you can use those to solve. All right, so I'm gonna just move us on. I kind of talked us through some of the connections that you might have noticed among the strategies, right? The fact that our 2 times 31 was double the 31, and then 8 times 31 is four times as large as the 2 times 31. If we had 9 times 31, you could have then just added one more group of 31, and our 11 times 31 is the same as that 2 groups of 31 plus the 9 groups of 31, right? And so a lot of different ways. That's like when we're asking kids to decompose the quantities, you kind of just did that right now. So I'm going to kind of jump us into our night because I'm looking at the time and I want to make sure we go through, and I kind of talked through a bunch of it already, but we're going to spend some time thinking about multiplication and division. And I'd ask you to think about this definition of multiplication, right? So multiplication is a scaling process involving 2 quantities. So when I'm thinking about scaling, I'm thinking about, right, making things increasing the size or decreasing the size by a certain amount. When we're looking in our earlier years, kindergarten, 1st grade, 2nd grade, really not talking through the lens of multiplication, but more about the ideas of groups. And I heard somebody mention that they use repeated addition. It's that idea of repeated addition. So in kindergarten, we might ask kids to put 5 counters on 3 different on each of 3 different 10 frames, right? So you could see there that you have a group of 5 on the top one, a group of 5 on the second, a group of 5 on the third, and then say like, how much do we have all together? And through that, students are not going to do necessarily 3 times 5, but they're thinking, well, let's see, if I have 5 plus another 5 plus another 5, that would give me 15. And oftentimes in kindergarten, they're still, depending upon where they are in the year, they might still be counting that 1-to-1 correspondence. As they move to like mid-elementary grades, right, 3, 4, 5, then students start to be thinking about moving away from that more concrete counter representation to maybe what more representations might look like, such as the apples that we see here, right? We'll draw those pictures of them and think about what 3 groups of 5 is. And here they start to begin in 3rd grade, that idea of 3 times 5, right? So we could see that if one group of apples has 5 in it, we're scaling it now to say we have 3 groups of the same, we would have a total of 15, right? And in our later grades, they're really thinking still with that same process of scaling, but involving numbers, more rational numbers like fractions and decimals. So when we scale something to be half the size, right? So if you have a group of 6 and you're doing half the group of 6, we could see that 1/2 of that group of 6 is equal to 3. Division, I want you to think about as the inverse of multiplication. Right, but know that division can be used to find two different ideas. You can use division to think about the number of units in one group when you know the number of groups, or you can use division to find the number of groups when you know the units in one group. For our younger grades, they're really just thinking about that fair sharing, right? So if we have those 6 cookies and you say, share them with you and your friend, how many cookies are you each going to get? Kids can easily say one for you, one for me, one for you, one for me, one for you, one for me, until they see that, oh, we each get 3, right? And 3 plus 3 is 6. So they're kind of thinking about it in that way, but still doing that process of splitting things up. And Cynthia, yes, I think the slides will be shared. Lewis, we could also share them, right? In mid-elementary, right, so again, that 3 through 5, they're really developing that concept of division and how it relates to multiplication. A lot of times they're doing this in tandem, right? So when we're thinking about multiplication, we might also be thinking about division. And so here we could have that same question. You bake 6 cookies to share with a friend. How many do you get? But now they're really thinking about it as the 6 divided into 2 groups equals 3 in each group, right? And we'll see that 6 divided by 2 is 3. Another way to think about multiplication, so that's that we know the number of we know the number of cookies that we started with. We know the number of groups that we have, and we wanted to figure out how many are in each group, right? Another way for the same problem, thinking about the context, is if we share 6 cookies so that each person gets 2 cookies, how many people can you share with, right? So now you have 6 cookies and now everybody's going to get 2. How many people can you share with? Now you're dividing that 6 groups into groups of 2 to find out 3 groups, right? So that's when we have the number of groups and, the number in each group, the number of units in one group, and you want to figure out how many groups. Going to the later grades, now multiplication and division, now division is really going to focus more on those use of rational numbers. So things like decimals and dividing by fractions. And this is where the math starts to get even more confusing for kids who don't have a solid understanding as to what division means and how it relates to multiplication. So for example, we could have those same, we could have 6 people, and 6 people are sharing a half a cookie, and we want to know how much of the cookie is everybody going to get. So we have that half a cookie divided into those 6 groups, and again, thinking about how it relates back to that whole cookie, everybody's going to get 1/12 of the entire cookie. So that's our division in middle school. And then that same, taking that same 1/2 divided by 6 in a different context and thinking about how it really, how our models look different and what the division really means and looks like. We could say for any of us who like to bake, let's say you only have half a cup of sugar, but your recipe calls for 6 cups of sugar. How much of the recipe can you make, right? And so knowing that is going to help me also to think about how I might have to scale all the rest of my ingredients. And so if the entire recipe calls for 6 cups of sugar. We see our bar model there representing those 6 wholes. I only have half a cup of sugar. And how much is that in relation to the amount that I would need for the 6 cups, right? So it would take me 12 half cups to make the whole recipe, but I only have 1 of those 12 half cups. So I could only make 1/12 of the group, right? And so that there for anybody who might be struggling to think about what is she talking about, this is where the math starts to get really tricky for kids when we're asking them to think about division, especially, right? And what that means, and when to use what our models look like, and when to use division versus multiplication, especially in the middle schools, and how do we set up our word problems. Okay, so we're gonna watch just it's about 7 minutes video. And then about division, because I really just want to go into that idea of division. I feel like many of us probably have a strong foundation and understand multiplication, but really want you to pay attention to how division also progresses through the earlier grades. So, and there is a Spanish version here as well. All right.
Of all the things that students must learn by the time they leave elementary school, division might be one of the toughest. So here we look to tackle the progression of division, and it starts in 3rd grade. So take this for example, 12 divided by 4. Let's see what happens. Well, we have two completely different models. And what this says is that the context, the story of the problem, plays a large part in developing students' conceptual understanding. In one, we have 12 bears with 4 in each group, which gives us 3 groups, and 12 bears shared with 4 friends, which leaves us 3 with each group. One model, well, that's measurement or repeated subtraction. The other is fair share, which I think we're all pretty familiar with. In one example, we have the group is unknown, and in the other, the size of the group is unknown. As students begin to develop their understanding of division, they probably begin to really rely on this fair share model. But 54, that's going to take a long time using fair share. So we need to put students in a place where they begin to become more flexible and efficient thinkers. So they might begin, instead of doing 1 by 1, they might say, I'm going to take out 5 and put 5 in each group to start. Then with their remaining pieces, they might put 2 in each group, and so on. So within each group of 6, they've placed a group of 5, a group of 2, and another group of 2. So when you take 54 and you divide it into 6 groups, you get 9 in each group. Now here students are making the connection between the concrete, the representation, and the abstract. And you know what? It all makes sense because students are building these pieces conceptually. As students begin to explore again in 3rd grade, they deal with quotients which are greater than 10. Here students might begin to explore the idea of division with base 10 blocks. So they'll start with 72, and instead of putting it into 3 groups, they'll put it into 3 rows. They'll start by placing 10 in each row, then 10 in each row, and then they have that 10, and in order to place it in each row, they need to decompose it, make a fair trade. So you can see that when we take 72 and we divide it into 3 rows, we have 24 in each row. And then we want to make that connection from the concrete with the base 10 blocks to the representation. And how do we record our representation in a written expression? And some students might begin to collectively group their 10s, and that's where the 20 came from. The best part about this is that students are making a connection back to multiplication by using the distributive property, and they're seeing it visually. In 4th grade, yeah, that's right, all that understanding we just saw should have been happening in 3rd grade. But it might not be mastered. But in 4th grade, students will take 4-digit dividends and 1-digit divisors and begin to extend their understanding of division. But one thing has to be taking place, and that's continually making the connection between models and representations and written expressions. Here we'll take 144 and divide it into 9 groups, 1 into each group, and so on and so on and so on. Again, that fair share model. But what does that model look like as a written expression? Well, here the students repeatedly removing groups of 9 from the 144. Now, is this efficient? No, not at all. But it's really important that students work through this step. and they realize what efficient and non-efficient thinking looks like. So after students do the example of 144 divided by 9, we might throw them in a place with this number, where the dividend is 3,672. Well, they start removing groups of 9, and immediately they say, oh wow, I'm going to be here forever. This is going to take the longest time. Can I take out a group of 100? Sure you can. You can take out whatever groups you want. So they can take out a group of 100, a group of 200, and then another group of 100 nines, and then a group of 6 nines. Students have to make sense of the mathematics, and we can't tell them what to do. So here, they're removing their partial quotients. So from the expression, they go ahead and create an area model. And what's beautiful about this area model is that it connects back to multiplication, except it's the area model for partial quotients. Then, as students begin to dive into 5th grade, they extend this understanding that they've built conceptually from 3rd and 4th grade, only this time they deal with 4-digit dividends and 2-digit divisors. The big piece here is that students deal with numbers and equations where they'll only have whole number quotients. All that means is that the decimal shouldn't be in the answer, but it can be in the dividend, and we can have a decimal in the divisor. So here we make that connection again between the representation and the expression. And we write our partial quotients off to the side. Just helps us keep track. So students might not know all their multiplication facts, but they do know 3 or 4. So here's their products of 32. Every student will know these. Let them start there. Now, decimals. What about decimals? Well, this same understanding of partial quotients and area model can be applied to decimals. Here we have 1 and 24 hundredths, and we're continually removing groups of 400ths. Connections are being made, and it's a progression, which makes it much easier for students to move between whole numbers to decimals and from decimals back to whole numbers. There's just an example. Instead of using 3/10, a student might think flexibly and use 25 400ths. Now in 6th grade, students encounter the term standard algorithm. And all that really means is a series of repeated steps. So if students have used this same understanding of partial quotients from 3rd grade, this is a standard algorithm. So let's see what a student might do. Well, in 8,425, I want to take out remove 200 groups of 32, and then 60 groups of 32, and 3 groups of 32. Let's look what it looks like with the standard algorithm. Well, 32 doesn't go into 8, but 32 goes into, what does that mean? And here we have the traditional algorithm, which many of us are familiar with. But you see how there's a connection between the two. Which one has understanding? So there's lots of things taking place, all the way up from 3rd grade to 6th grade. Let's not rush it. Remember that the turtle won the race.
Okay, and so I know the video was a little bit long, but I think it does a really good job of helping us see how division starts off in the earlier grades and progresses all the way through till 6th grade, where they're supposed to have that like mastery of the standard algorithm is supposed to take place, right? And as we look here, I'm not going to show you the video, but there's a video for multiplication as well. If you look at our his drawing for multiplication, a lot of the models that he has here relate back to the models for division as well. So students are making the connections between the types of models, those area models that they were using for multiplication. Here we can see the base 10 models, and then also that repeated subtraction, that repeated addition, all are connected to each other, right? And so just to kind of talk us through a little bit as to how multiplication and division kind of starts, not necessarily starts in kindergarten and 2nd grade, but we're building that foundation, right? In kindergarten, they're exploring equal groups sometimes, and that idea of repeated addition. You might have 2 plus 2, or 5 plus 5, or 6 plus 6 when they're doing that doubles, right? In first grade, they're skip counting more fluently, so they're counting by twos, fives, tens more fluently. They're also beginning to represent equal groups with repeated addition and modeling their drawings of repeated addition. Thinking also about some of those sharing situations, right? What does it mean for us to have 10 cookies that we share with 2 friends. And then in second grade, they're beginning to use some of those arrays and equal groups. And they're beginning to just think about division, but only through the lens of an unknown group size, right? So if I have 12 cookies and everybody, I have 3 friends to share with, or, there's 3 of us to share with. How many does each person get? What's that unknown group size, right? Or the unknown total. And they're also thinking about determining if a number is even or odd. So again, splitting into groups of 2 equal groups to think about if things are even or odd. In third grade is where that's where that heavy learning of those multiplication and division facts within 100 start. And by the end of third grade, they're expected to know from memory all products of 2 one-digit numbers, right? So that means like 8 times 8, 9 times 9, all the way up to there. No, from memory, but that doesn't mean necessarily that they have to be able to say it like this. They can also think about, if I know, let's say 2 times 4 is 8, and now I have 4 times 4, I could double my 8 to get 16. They can use strategies like that. By fourth grade, they're learning to, as we saw in the video, where they were thinking about even dividing multi-digits. They're also multiplying multi-digits, thinking about division with remainders, and they're really focusing in on place value and the properties, which is why in the video we saw him talking about taking away groups of 100, taking away groups of 10. And then in fifth grade, the multiplication and division includes, again, multi-digit numbers, 4-digit numbers. They're multiplying 4-digit numbers, and then they're also dividing 4-digit by 2-digit. They're also beginning to multiply by decimals, especially in terms of powers of 10, and then thinking about multiplying fractional sized groups, right? So if you have a group of 3, how much is that? And in fifth grade, for multiplication only, that's when that standard algorithm is expected, right? So up until now, up until fifth grade, students can use a variety of strategies to multiply or divide. By fifth grade is when they're only expected to use that standard algorithm, which is what I think let's see, it was Cynthia who said, so different when we went to school. That's when kids have to master that standard algorithm. In middle school, they're multiplying and dividing with fractions and decimals fluently. And now is when they're expected to understand that standard algorithm for division, as we saw in the video. Also thinking about how multiplication and division applies to ratios and proportions, how it applies to integers, and then for 8th grade in algebra, thinking about how they're using multiplication and division to help them solve linear equations, functions, and exponents. So really just that application of those 2 operations. In K-2, they're thinking about, again, building that foundation, lots of skip counting, simple grouping. They're writing equations that match their models using that repeated addition. And they're using number lines to make equal jumps. In 3rd through 5th grade, they're representing things using multiplication and division, thinking about those properties, the commutative property, the associative property, how they help with multiplication, and then thinking about multiple methods before they learn that algorithm, as we saw Graham Fletcher share with us. Again, from 3rd to 5th grade, we want to really start off moving from the concrete to the representational to the abstract. In 6th through 8th grade, students, again, are applying their understanding of multiplication and division to working with rational numbers. They're moving between fractions, decimals, and percents fluently, and they're solving and simplifying algebraic expressions using those 2 operations, and also thinking about how they could use multiplication and division to help them develop general rules from patterns in algebra. So let's just take a quick look at our Amplified Desmos curriculum and what makes this unique. I talked about this a little bit last time, but wanted to just talk about it through the lens of multiplication and division. So it is a problem-based learning curriculum. Our students are learning through tasks, not just like the teacher showing them how to solve it, modeling it first, or just doing all the talking. The students are really engaged in conversation about how they solve the problems. They're using drawings, they're using models, they're using number lines, and our tasks are really encouraging reasoning, helping them to understand the concept versus just being able to solve things quickly. So we could see here from third grade, what do you notice? What do you wonder? Piece of a task. Here, students are asked to think about, what do I see? Will I see 4 plates of apples with 5 apples on each? I also see 4 dice that have 5 on them, and I'm thinking about like, how much is that total, right? Or why are they showing both those representations? I could see 4 groups of 5, actually 3 ways in the expression, in the dice, and in the apples. And they have conversations around how they're the same, how they're different. The curriculum also has a lot of routines built into it. The routines are designed to support building fluency and reasoning, and also student understanding and discussion. In kindergarten, I actually shared this one with this how many do you see in the addition and subtraction, in terms of like students are counting, they might be counting one by one for those dice, right? But they might also see that like I have 2 dots on one side, 2 dots on another side. That's 4, and 1 more is 5, right? So that's where we see those groups of things happening, or 2 dots up top, 2 dots on the bottom. That's 4, and then 1 more is 5. In our greatest value in grade 2, right? So it's like which one has the greatest value? They could be shown a bunch of models here. And students might be thinking about, oh, I see 6 groups of flats or hundreds, right? So it's 100, 200, 300, 400, 500, 600, or they might just know 6 groups of hundreds is 600s, right? And then I have 4 groups of 1, that's 4. So I have 604. Not necessarily, we see the addition coming in, but you could hear where they're thinking about making those groups of numbers and how much those equal in total. In C, you might see that they have 6 groups of 10. So what does that sound like? 10, 20, 30, 40, 50, 60, and then 4 groups of 1, right? So we have 64 there. And so they're using that skip counting. They're thinking about the groups of the same number, which is all going to support them when they move into third grade and start really digging into multiplication. In fourth grade, there's these routines also live across all the grades. I'm just giving you samples of some of them across the grades. So in fourth grade, here's an example of a which one doesn't belong. They're shown 4 different types of expressions and asked to think about which one doesn't belong with the others. And hint, you could say any one of these doesn't belong with the others. It's just about what you're paying attention to. So we see here an expression of 7 times 50. So just the 2 standard, the standard numbers. We could see also in B that the 7 has been decomposed into 3 and 4, right? So we have 3 groups of 50 and then 4 groups of 50, similar to like that number talk that we started off with, where we were combining our answer for 2 times 31 and 9 times 31 to get it. In C, we see again where our 50's been decomposed into 5 groups of 10, and then thinking about multiplying by 7. How does that help us? And then I heard even some earlier say about repeated addition. In D, we see that addition of 7 groups of 50. We talked about our number talk already. In algebra, here's what some multiplication can look like. We might see a notice and wonder. They're asked to look at a table and maybe think about like, what's the pattern that you notice here? They're looking at the days, how much they're increasing. Those are increasing by 1. But when we look at the purple globs, they're increasing by ×3 as much. So what is that making me think? Maybe making me think like, how do I get from 2 to 6? How do I get from 6 to 18? I'm thinking exponentially, right? So I have to think about how my blobs or whatever it is growing exponentially. So that idea of multiplying by the same amount every day, right? And what does that even mean? Okay, so in our Desmos classroom, right? We across K through algebra, students have opportunities to engage in digital lessons using some of those digital tools. And just know, like in K-2, if when we do start using it, K-2, the amount of digital lessons is really about 1 or 2, maybe a unit. So there's not that many opportunities for kids to really like be engaged in so many digital lessons. It's mostly paper-based. In 3 through 5, there might be like 3 or 4 activities within lessons within a unit that teachers have an option to use digitally. And then in 6 to 8, there's about 75% of the curriculum has an option to also be digital. So I think teachers that in our middle school and our schools in elementary school that are really using a combination of both and being strategic as to when they're using them. But our digital lessons are really great because they allow the students to play around with some visual models. Their representations are interactive, and they get some instant feedback. So, for example, here in the image on the left, you could see they said create 2 rectangles that compose a 7x6 rectangle. This is 3rd grade. Find as many as you can. I purposely made an error here so that you could see what happens, right? So the kids can see up in that top left-hand corner, there's that exclamation part. I made a mistake. Here's what my response actually looks like. So I actually can see that, oh, I made it too long. That 5 is too long. And then the 3 that I had up on top is too short. So like, how can I make that? So I can go back and try again and see that one way I can decompose 6, a 6 times 7 or 7 times 6 is to do 3 times 6 and 4 times 6. Make a rectangle that's 3x6 and one that's 4x6. And then I can combine those responses, the 18 and the 24, to figure out that it's 42. There is coherence across the grades in case we haven't seen that yet, right? So we really want students to really understand concepts first concretely, and then thinking about the engaging with some representations that also can be used to represent the concrete, and then eventually towards that abstract. So in 3rd grade, we see the use of arrays to understand 4 times 5 and 5 times how that equals 5 times 4. I'll show you a clip of that in a minute. And then we have our area model, and then eventually to our partial products in 5th grade. So quickly, if you'd like to join the lesson, you can join the lesson here by clicking or putting in that code. I will leave it open so you can also go back and forth through it even after the session if you want to take a look and play around with some of the slides. But you can join the lesson that way. I'm just going to open my slides here and show you a little bit around what some lessons might look like. Sorry, just trying to make it a little larger. So in 2nd grade, for multiplication and division, again, it's not necessarily calling out multiplication and division because it's not a 2nd grade standard, but in an Amplified Desmos lesson, they might be asked, sorry, I was playing around with it. Let me just clear off my stuff here. They might be asked to play around with the types of jumps that they can take to get from 41 back to 32. And if you notice, the types of jumps they can only take are 10 big, 5 big, 2 big, or 1 big. So I was thinking, let me start at 41 and take a couple of jumps of 2. So when I do this, I can see that if I could take 4 jumps that are too big, so that would be that 8, and then I need 1 more to make 9, right? So not naming it as 4 times 2, but 2, I might be counting 2, 4, 6, 8, and then 1 more is 9. I can also think about if my jump that was going backwards Also thinking about if I'm starting at 20 and I am making jumps from 20 up to 43, what size jumps might I want to take? I'm going to take bigger ones. Again, this is still like that addition, but I'm thinking about it in terms of larger size groups and how many of those groups I could take. So I could take one jump of 10, another jump of 10, and then I might have to go to my smaller one. So two groups of 10 is 20, right? 10, 20. And then I have three groups of one, which is 1, 2, 3, or 3. So three groups of one is 3, and that gives me that 23. So second grade, you can hear how some of the work that they're doing is going to build towards what they need to do in third grade. In third grade, they're thinking about arrays and how they can use the arrays to prove that 4 times 5 is in fact equal to 5 groups of 4. And I should say 4 groups of 5 is equal to 5 groups of 4. So if we watch our video here, I think I might need to restart it. Let me come back to here. Sorry. If I watch my video, I thought it played both. I'm looking at it wrong. Sorry. I think that one just shows how we can use arrays. And then I think in the next one here, we can see how the 5 groups of 8 is equivalent also to the 8 groups of 5. We can see that they just kind of like flip over and have the same amount of scoops to equal there. The lesson goes on, but just showing you how the interactiveness also helps kids see that commutative property, right? That 5 groups of 8 is the same as 8 groups of 5. So just for time purposes, move us on. In fourth grade, what do we look like? Now we have the area model. So kids are looking at some area models, thinking about how they're the same, how they're different. We see the three rows on each side, right? But the number of columns is different. Kids might see something like there's a group of 6 within each of the 15 and 21 as well, and use some of that relationship. Then here, they're also thinking about coming up with some of the rectangles that equal that. Sorry, if you have a group of 5, what would those look like, right? And I guess I was playing around with it and stopped. I didn't clear that out. Sorry about that. And then here we have another number. So we're thinking about 8. What would be another area model that they can have? So like they could have 8. They could have 24 if they're counting 8, 16, 24. Using some of their skip counting skills from earlier grades, and notice that that is 24. What's the relationship? It's 3 times bigger because I could see that there's 3 more columns of it to help them think about how they might use one product to help them find the product of another one. And then finally in 6th grade, they're taking a look at the bar models, excuse me, not the bar models, the base 10 blocks, excuse me. Now the base 10 block is worth 1 whole versus that 100, which we saw in earlier grades, and thinking about how they could use that 1 whole to represent, pretty much using the area model, 5 tenths times 7 tenths, and they can see why it's less than 1, that it's only 35 hundredths, right? Again, multiplying 4 tenths times 2 tenths, they can see why it is only 8 hundredths, right? So it's 8 hundredths. There's only 8 little boxes out of the 100 that takes the whole there. And then again, seeing even what happens when we have smaller numbers. What if we had 8 tenths? Sorry, I just can't see my screen at the bottom. Times the other number that I can't see. Sorry, 3 tenths versus 8 hundredths versus 3 hundredths. We could see that each time we change the value of our factors, like it gets even smaller. So when we're when our decimals are getting smaller or multiplying by another decimal that's smaller, the amount gets even smaller. So we're in the thousands place there. So that's pretty much an Amplified Desmos lesson. I do challenge you to kind of go through it if you'd like to on your own and play around with some of the slides. Just really quick, I know we saw a bunch of the models throughout our time today. You can take a look back. I know Louis shared the slides. Here's some models that you might want to think about using with your kids if they're in 3 through 5 to help them with that multiplication and division, thinking about making those circular groups of things, progressing to more of that area model, using that bar model also then, so we could see more of that concrete to the representation, more to the a little bit more abstract with the bar model, then to just even thinking about the numbers, maybe in terms of their primes, and then even using in the bottom where we have the 12 and the 6 at the top, what number would be the width, right? So that area model, thinking about that multiplication problem to help me figure out 6 times what number gives me 12, really, right? So we see that inverse of multiplication and division, and some bar models for division. In K through 2, sorry, this should have been first. Here's just some ways that some different models that kids might be thinking about. The fact that we have 2 hands with 5 on each, right? So I have 2 groups of 5. How much is that? That's 10. There we could see right there. If we're playing concentration, they might have a model of 2 pairs, two pairs, and each pair has 2, right? So how many cards do you have? I have 4 because I have 2 pairs of things. I have one pair of the leather cow and one pair of the wool. And then also thinking about those base 10 blocks, those 3 groups of 10 blocks gives me 30. Going to division models, I think we saw them in the video here, but if you'd like to unpack them, learn a little bit more about them, I kind of put some samples here for you to look at also. We can see that area model versus Claire's work, which is more of the multiplication model. It looks like I have some errors there. Sorry, this should be multiplication and division. We have multiplication at the top and then division at the bottom, and then division on the right-hand side here. So on the right-hand side, we see the traditional algorithm versus that partial quotients that we saw Graham Fletcher talking about. In 6th grade to 8th grade, thinking about some of those models that can be used to represent multiplication and division. Again, we see the area model with the decimals. When they're thinking about solving equations, you might have that balance model. So 1 hard is 15, 3 purple squares is also equal to 15. How much is 1, right? So thinking about that 15 divided by 3 to find that 5. We also can see decimal division again being used with those base 10 blocks, right? The flats we see here broken up into 10 groups of 10. And then again, making that connection on the right-hand side between that partial quotients that we saw Graham Fletcher talking about versus the standard algorithm. And then as we move towards the later grades, maybe even thinking about it just in terms of tables. If we have negative numbers, you're walking negative 17 feet in 5 minutes, which means you're probably going down the mountain, then what's your walking rate? How far are you decreasing in feet as you walk down the mountain in 1 minute? So don't need to answer. I know we're at 8 o'clock, but just even thinking to yourself, what did you notice about how the math changes across the grades? Anything that surprised you? Some at-home resources. These are pretty much the same as what I've shared last time. We have our tips for parents and guardians here. Just some different things to think about today. Really thinking about when you're learning multiplication and division, what are some homemade math materials or some things, some manipulatives that you can take out to support your kids in who need that support and actually showing the physical making of the groups or the physical splitting of the total amounts into groups, right? You might want to also, I heard a few people in the chat saying something like, this is not how I learned it. I'd ask you just to really think about trying to understand the way that your teacher is asking your child to do math, even if you have a way that makes more sense to you. A lot of times we're trying to help the students understand the concept that will then eventually get them to really understanding why that shortcut works. I feel like a lot of times if I ask you like, why does keep change flip work for division of fractions, many people have a hard time explaining why that works. So trying to really think about what your student is learning at school, trying to understand that. And I think coming here is like the first step. Um, some questions you can ask as we're doing homework might be like, what do you need to figure out? What's the problem asking? What models are you using in class? Can you describe where you're stuck? What's confusing? Let's try to draw a picture. Does your answer make sense? And just some next steps and some resources. Here are some of my favorite things to do to support math conversations at home. The bedtime math, I shared it last time, but I think it's a fabulous resource. Definitely gives you like a little scenario that you can talk about with your kids before bedtime and how to think about, gives you some math questions to ask the kids based upon their age. So we have like pre-K to K, questions for earlier elementaries, questions for later elementary, and even some earlier middle school. Another favorite game that's been super hot at our math nights. Our math family nights is this multi game over here. I did put the link to Amazon. I don't get any money, so this is not a link that's going to get me any money, but just sharing that with you and those figure this math challenges. Additional resources that we mentioned tonight, you can go look at some of those other progression videos that we just shared. There's the Caregiver Hub for Amplify Desmos if you want to take a look at it. Some virtual manipulatives if you want to work on those on the computer. And then an article that kind of can also support you in better understanding those multiplication and division models and strategies. And that's it. Any questions in the chat? Or come off mute. Put your hand up and come off mute.
So a few comments in the chat that you can go through.
Yes. Okay. Can I add more videos for tutoring for parents to better support your children? Sure. I mean, I know another place that people often like to look. It's not always my favorite one, but like Khan Academy does have some videos that are aligned to the Amplify curriculum. Once we do transition K to 8, Amplify does also have some super helpful videos that can be shared with students and families to watch at home to also support some of those. And then somebody said, Amplify, can you please add more tutorial videos? I only got to lesson 2. Sure, wasn't sure what that. I think that's what I think I answered that one. Is there an online resource where my kids can learn 4th grade fractions? Again, I would say like Khan Academy, maybe. I feel like I have to have Liz. You have any good videos that are maybe more conceptually based for fractions?
I think that's something that we can try to compile over
Yeah.
time and make available on our district site especially for families that are looking for it. Something we can certainly add to our website resources for all of you.
Yes, and Khan Academy is a favorite one. They're pretty friendly in terms of like the format for the students and also for parents. And then sometimes on YouTube, you can even put in a standard that's causing you a little bit of an issue, and some really good things will come up. And I always love to just ask our educators, ask our teachers what they have in mind in order to support, and we will definitely work on that.
And I
Yeah,
think
and I think through
Lewis.
that feedback, it serves as an opportunity for us to make a little bit of additional toolkit opportunities for you as families. And I know that our schools do that, but it is something that we can start looking into a little bit more as well. So that's great feedback.
Thank you, Jenny.
And I just want to thank Beth and Liz for presenting tonight, and I thank all of you parents for being on here. As I was listening into the presentation myself, it was just important just to kind of see the progression on all of the things that start at such a young age that we don't realize build those muscles for our kids in terms of making those groups early on, all the way through the time they get into eighth grade, and how one builds on the next. In terms of the sport supports for our students that have some additional needs, building these things through this conceptual space is part of doing that. That's part of the building that's necessary. Those representations, those models, those relationship building that Beth talked about a number of times tonight are the things that are going to help some of our children that are struggling in mathematics to get over the hump. So thank you, Beth and Liz, for organizing tonight.
Thank you. I also think like playing some games, right? Like as another way to just kind of support. So we saw in our math night last week, so many families like engaged in math games. And while maybe the conversations weren't having around like what you were doing, we were doing the math, and it was like the more that we're doing it, the more just trying to build in a question like, hey, what made you think what made you do that move, right? Or like explain to me what you're doing there. Like where do you see, even in my multi game that I shared, you can see like the actual number of groups in the visual models that are there. So like there's some really fabulous math games out there that can be used to support students in learning math, but doesn't always necessarily feel so much like a worksheet that they have to fill in, right? And makes it a little bit more fun. All right.
Hi,
Hi.
sorry, I just
That's okay.
for chiming in. Yeah, you just mentioned about games. My kid would really like games, and to a point where uh I have to stop her. But I really liked your suggestion of spending time with games and not even feel like she's learning something. What do you have any website, any online resources, links you suggest that we can go online and play some games there?
I do. Let's see. I don't always I mean, my resources, let's see if this is the right one. Um, I think this is what I did. I'm just looking for what I shared with. Yeah. So here's what I had shared with Marissa, I believe, and I think this was sent out in one of our um sorry,
Yeah, I would
I'm
really
just
appreciate
looking for
if
the
you.
chat feature. Sorry about that.
Oh,
I have to
okay.
go back.
Okay.
So here's a resource. I think, Lewis, it's in our folder. If I share it, they should be able to open it. Do they have access to whatever is in that parent folder?
Yes, they should. Yes.
Yeah. So there's a list of like different types of games that are good for math learning, whether they're board games. There's some also digital, and I'll continue to update to this and share this with everybody as well. We can add some videos that are great for each of the different content areas as well. So I just kind of threw together a few things, but um, there is a list of some games here. I'll add to this even more and then resend it out to families so that you can see additional things that I've added to there.
Awesome. Thank you so much.
You're welcome. Any other questions?
I'm going to ask our interpreters, are there any questions in the interpretation rooms?
No, no questions on the Spanish line, thank you.
Thank you.
And no question from the room.
Thank you very much. So Cynthia's asking in the chat, just to me, how do we open Amplify using the link? They are not asking for the link. So when you click on that link, and I'll put it in the chat again to go through the lessons that Beth kind of briefly demonstrated. When you go to that link, it's going to ask you to log in, but next to it, there's an option to continue without logging in. So you're going to go ahead and click that option, don't log in, and then you're going to enter your name. You can put whatever name you'd like, and then you'll be brought right into the lesson. You can progress through all the different pages and play with the different activities. Is that correct, Beth?
Yes, thank you.
Hopefully that works for you. All right. So if there's no other questions, we're going to wrap it up for the evening. This session was recorded and it will be posted on our YouTube channel. So please head over to our website and subscribe to the YouTube channel to get all of our uploads, notifications sent to you. And Beth, anything else? Or Dr. Mike, anything else?
No,
I'm
I
sorry,
think.
this
Oh,
I'm
sure.
sorry, this is Cynthia. Before you can even explain it, I closed the chat and I feel like an idiot. So do you mind doing?
You muted yourself, Cynthia.
Yeah, you mute yourself on accident.
I'm sorry.
It's okay.
Can you explain it one more time?
Yeah,
I'm so
sure. So I
sorry.
put the link in the chat again, so you have
Yeah.
it at the bottom. And then when you click on it, it should prompt you to log in. But next to that is a button to continue without logging in, and that's the one you want to click. You don't want to log in.
Okay, got it.
And then it'll just ask you for your name, just type in your name, and you'll be brought right into the lesson, and you can experience the Amplify platform similar to how kids experience it.
Oh, okay, so it's not necessary because I saw that there's like a code at the bottom, like that V code. So we don't need any of that then.
So that code is actually part of the link already. So if you look at the
Oh,
link, it's already in there. So when you click
okay,
on
got
that link, it should just bring you right in. You're going to say continue without signing in, enter your name, Lewis, and I'm in.
Awesome.
Yeah,
Thank you so
17
much. You guys
pages.
did great. Thank you so much.
Thank you.
Oh,
Our final session for this series will be at the end of May, and we do also have another math night coming up. I want to say March 26th, I believe, at Junior High School 189. It is for K-8. So if you'd love to come, we'd love to have you. It's always a fun night. So that will also be posted on the website as well. And for anyone whose kids, we have a 3 through 5 Game 24 tournament. Some of our students across the districts are involved in that. That's Friday. Can't wait to see that and all the math thinking and conversations that are happening with our 3 through 5th graders as they engage in the Game 24 tournament. So more to come on that. All right, thanks.
Just thank you, Beth and Liz and Lewis, as always, for doing your thing. Parents, have a great night. And if you need anything, please know that we are an email away, and we'll be there to support you. So thanks so much, everyone.
Thank you.
have a good night, everybody. Thank you.
Thanks, Beth. Thanks, Louis. Thanks, Liz.
Thank you.
Of
Have a good
course.
one.
Good night, everyone. Thank you.